So to start our spinning ring, we are going to put a long piece of aluminum into the lathe, make sure it's nice and tight and centered in the lathe. We are then going to find ourselves a center drill in the wooden cabinet, as well as a small drill that is the size of your finger, but it needs to be a little bit smaller as we will be expanding the ring.
A good size for our finger, so we're gonna expand it out with a round.
We also get a, call it, start by putting the center drill into the lathe. We can then start the lathe at about 500 RPM. Make sure the drill holder is tight with the brake on. We do need the lateral movement brake to be off to be able to move it.
Lower speed.
Let's start the spindle. We can slowly moving the center drill into our piece of aluminum. Using some cutting fluid to make sure the process goes well. Then remove the center drill and replace it with the drill you chose earlier that is a little bit smaller than your finger.
Works, that's
Tighten it in. I'm going to lower the RPM of the lathe down to about 300. Using some cutting fluid. Slowly move the drill into the piece of aluminum. Take your time. Remove the drill. We are now going to start shaving down that outer edge to turn the hole into a ring. For this I'm going to be using the right hand cutter tool at about 800 RPM. So we move it across the face, not taking more than a millimeter off each pass. Now, gonna get the chamfer tool out to put a small dip into the ring where the second ring will go. I'm going to drop the RPM down to about 500. And I always start by not moving the chamfer tool too far into the ring as to not cut it, and move it across to the thickness you want the moving part to be.
I didn't mind.
I'm going to be putting the parting tool on to cut this ring out of the piece of aluminum. Also making sure the parting tool is centered on the axis the piece of aluminum is spinning on to make sure it cuts well. It may not cut properly if it's too high up or too far down. Using some more cutting fluid. Towards the end of the cutting with the parting tool, just make sure to go slow as to not dent the ring. When I took the ring off the end of the bottom, it did have a little extra aluminum on the outside, which we'll cut off later. But now we're going to get a second drill, and now this drill has to be a little bit bigger or exactly the same width, diameter, as our inner ring that we just made. This way the second ring will fit over our inner ring and be able to latch on. Putting this drill the same way we did with the other drill.
Yeah, just loud and straight awkward. Sounds fun.
Make sure the brake is on before cutting. And again, we're going to drop the RPM down to about 500. Using some more cutting fluid. And remove as much material as needed. The outer ring won't be any thicker than the hole or the bevel edge you cut into the inner ring. I'm going to increase the RPM back up to 800 to use the left hand cutting tool. We're going to face the edge just to make sure it's smooth and then cut across. The thickness of this ring shouldn't be any less than the deepness of your bevel in the inner ring. However, it shouldn't be too thick as to be annoying. Now we're going to use the parting tool to cut the outer ring off the piece of aluminum. Again, we're going to drop the RPM down to 500 or 300. And use appropriate cutting fluid. Now, this part is important because we need to make sure the thickness of the outer ring is very, very close to the thickness or less than the thickness of the beveled edge in the inner ring. You can do this by putting the inner ring on top of the cut, making sure it slips in and goes back and forth. You can sand this down later, so don't make it too small. Now we're going to remove the parting tool and make sure you clean up any mess you made on the lathe, as well as remove the large piece of aluminum. Disengage the spindle. We're now going to use the belt sander in the back of the shop or anywhere to sand down those extra pieces of aluminum on the two rings and make sure they're sized correctly. Now we're going to use the polisher near the jewelry cabinet to polish down all the edges and the inside edge of the inner ring to make sure it all slides together properly. This might be the last time you'll be able to polish it, so make sure you do a good job. Especially make sure you do a good job polishing the bottom of that inner ring so the outer ring slips properly and smoothly. Also make sure you clean all this very well. Next, we're going to use the files to file down the inside of both rings. The jewelry cabinet files make this very easy and make a very fine finish with no hard edges, which is exactly what we want. Make sure you get this on the edges to deburr them, and as well as this generally the inner ring. If you just keep filing the inside of it, it makes it very, very smooth and nice to wear. Finally, we're going to move over to the ring expander to expand that inner ring onto the outer ring. While doing this, I'm putting the outer ring where it's supposed to be on the inner ring to make sure it's not get stuck. Also, as you notice, when I expand it, it kind of creates a taper where one side is smaller than the other, so I flip it back and forth to make sure it's nice and parallel, as you don't want the final ring to be smaller on one end than the other. Once it's on, just be really careful and don't make too many big moves, as the ring can expand too much and get the outer ring stuck and it won't spin. So take your time. If the inner ring does break, you can just go back to the lathe and make a new one. It does happen.
The aluminum is scrapped. So weird.
Aluminium.
fucked up yet. Not yet.
You're in the shots.
Just really careful making good use of that ring expander. The outer ring may bounce around a little bit, but you don't want the bouncing to be too much. Even if it's still inside the inner ring.
Oh shit. It works.
Is my face in it?
And but you want a broken ring?
Next, we're gonna grab a ball like this from the hand press near the large polisher. I just took a little sledgehammer and banged it against the ring on a wood table, just enough to put too much pressure, bend the metal too much. We're doing this to make the edges on the outside squish down on the outer ring to make it so it doesn't move too much. So the more you smash it, the less it will move. However, if you smash it too much, it may not move at all and seize up the ring. So just make sure to be careful and take time. That's about it for the aluminum spinning ring.